Welcome to the first real video in the Building a Web App from Scratch series. If you missed last week's video, we're going to be building a real-time checkers web application from start to finish. This series will be using ASP.NET Core and Blazor to build the application, but that being said, this initial design phase is totally implementation agnostic, meaning if you wanted to follow along with this series but use a totally different tech stack, for the most part, as much as I can think of, this design phase, this data design phase will be the same. So if you want to follow along to the series, make sure to subscribe, and I'll also link the GitHub repository for this project in the description so you can check that out as well. So to start planning out the database, I'm going to use an app called Lucidchart, and this is just essentially a diagramming app that we can use to just quickly start drawing out our entity relationship diagram. So before we start drawing out the tables, let's just kind of make a little note to ourselves about what's needed in this. And let me zoom in a bit here. Okay, so we'll talk about what kind of data we need to store, and then we'll figure out how to break it up into tables and how those tables are related. So we know that we'll have games. Each game will have players. It'll have pieces. There'll be locations of where pieces are located, like the game locations. Maybe there'll be moves. So this is all game specific stuff. And then app specific, we're gonna have users, which I am going to say is different from players, because a user is an individual person, an individual account that can sign into our app, but a player is specific to a game. You cannot have a concept of a player without a concept of a game. So a player is related to a game. A user is not. A player will reference a user and a game. Okay. So this is just our little side note for now. We might change this. This isn't saying these are the tables we're making. This is just kind of in our heads to think about the types of data that we want to store. So let's pull out a table here. Let's just start with a users table. So let's give it a primary key called ID, which will be of type int. And what things are specific to users? So maybe email. I'm not going to be super specific about these types either, just kind of general types. It'll have a password. They will have a password. There will be other stuff in here. I'm not going to dwell on this table, because what we're going to do in the future is actually use the users table from the scaffolded identity database that ASP.NET Core will scaffold out for us. So if you're not going to be using ASP.NET Core, or at least the identity system that comes with ASP.NET Core, you'll want to think about more specifically what type of information will go into this users table. But we'll touch more on this when we start talking about authentication. All right, let's add our game table, and we'll add our players table at the same time. So I'm just going to go ahead and give this a primary key real quick. Same with our players table. Players. And first of all, let's talk the players table. So the players table, a player is going to be a specific user playing a specific game. So we're going to have two foreign keys here, one that references the user ID and one that references the game ID. And so this will allow us to say that the game, let's draw these lines here. So a game has multiple players, and a user can be a different player in a game. Now, let's talk about the players table for a second. So the players table right now is acting as what's known as a join table between users and games, right? Because a game has many players. Each player is associated with a user. So transitively, a game has many users. And then you can follow that logic in this other direction. A user can be many different players each player is associated with a game, so a user can be associated with many different games. So that many-to-many relationship is being facilitated by this players table. So something to think about here is there's two ways that we could create this players table right now. One is that we have this primary key, which is just a primary key for the players table, and then we have two foreign keys, just like we have it here. What this does is it does not enforce any uniqueness in the combination of users and games, meaning that a game can have players that are the same user. So if we had a user whose ID was 1 and a game whose ID was 1, we could have a player ID, player 1, it's user 1 and game 1, and then we could have another player, player ID 2, with the same user and game, user ID 1, game ID 1. So we have to ask ourselves, is that what we want? In the case that if we were allowing players to play against themselves, then maybe we would want that. But in our requirements, it was specifically stated that there was not going to be any local multiplayer game. And even if there was, it probably wouldn't be the best way to handle that if we just had players that were both the same user. So instead of doing it this way, what we can do is create a composite primary key. So if we delete this ID field, what we can do is specify that these two columns together will act as a primary key, so that this will now say the user and game IDs together need to be unique. So you can have players that are all the same user, you just can't have players that are the same user and the same game, and vice versa. So in this case, a composite primary key makes the most sense for us to use. So let's move on and start talking about game pieces, so our checkers, and we'll talk about moves, which these two things will also tie into location. So let's first create our game pieces table. And by default, we'll say primary key ID type integer. Now, a game piece belongs to a specific game, and it also belongs to a specific player. So where does it make sense to start drawing relationships here? So if we relate a game piece to a player, then it also becomes related to a specific game because the player has a foreign key back to the game table. So since the players table has a composite primary key, we'll need to reference both of these columns in our game pieces table in order to make this relationship. So let's say user ID and game ID. And other properties about the game piece. So a game piece can either be kinged or not kinged. So we'll say is kinged as a Boolean. And then let's add another table here for game moves. And a game move will be, first of all, let's primary key. A game move will be on a specific piece. So we're going to, let's actually add foreign key flags here, just so we remember. We're going to add a foreign key to the game piece table. We'll just call it piece ID. So a game piece will have multiple game moves, moves plural. Now, what other information do we want in here? So we probably want to know, so we know which piece moved. We probably want to know where it moved so that we can keep track of the game state and where each piece lives on the game board. We also probably want to store the initial starting location of each game piece as well. So I'm going to add two fields into the game pieces table. And we're going to say start row and start column. So this will specify the location of where the game piece started. And so every game piece will have to have a starting row and a starting column. And a game move will also be moved to a specific row and column. So we'll say row and column. Now, an option that we have to us is to create a game locations table and have both the game pieces and the game moves table reference the game locations table. Right now, I feel like I don't want to do that, and I'm just going to have these coordinates here. But like any episode in this series, feel free to comment your opinions. You can leave your thoughts in the YouTube comments. You can also open an issue on the GitHub repository or comment on an appropriate issue or something to make your suggestion. This is kind of my thought process and where I'm at right now with the planning phase, but my argument for not putting it in is that I don't think it adds anything valuable, really. I think it would be valuable if we were doing any lookups that were based on the game location, but because each game is going to have the same layout, the same number of cells, the same number of rows, the same number of columns, I think what we'll end up doing is for each game just lay out that default game board, and then for each game piece in the game, look at where its location is and just show the game piece there. So there's not really any like lookup necessarily that we have to do for the actual location. Now, we're not enforcing things like a location can only have one game piece, for example, but I think that's just something that I'm going to just live with and say it's not worth overcomplicating it to put that restriction into our database. We'll have that restriction in our application, and for me, I think that's good enough. But again, if you have other thoughts about this, definitely let me know. Yeah. All right, let's finish this up. So the last thing that I want to add in here is captures. So the idea of a game piece can jump another game piece, and then that game piece is then captured and out of the game. So I'm going to add another table here, and I'm going to call this game captures. And let's call this, well, first of all, I'll just add a primary key here, but let's think about this. So first of all, a game capture will be related to a move, so which move a piece was captured in, and a piece, so which piece was captured. So a move can have multiple captures in one move. So let's add a foreign key relationship here and say move ID. And so this is now saying there is a one-to-many relationship where one move can have multiple game captures. However, one piece can only be captured one time in a game. Once a piece is captured, then that piece is out of the game. So instead of having this be a one-to-many relationship, I'm going to make this a one-to-one relationship. And our primary key is also going to be a foreign key to the piece ID, or to the piece table. So we have a game move can have multiple game captures, but one game piece can only be captured once. But a piece can be moved multiple times. It just can only be captured once. So that's what we're going to do for our game captures. And now finally, I realize this is just sitting here not being filled in. First of all, I want to make them plural so that I'm consistent with how I've named my other tables. The only other thing I think that I want to add in here is the game status, which I'm going to also make another table for. And so the game statuses, this will be things like active, expired, completed. So let's say primary key. This can also be, let's see, status text. This can also be like pending. So when there's just one player in the game before the second player has joined, the game status can be pending maybe. And let's take that extra column away. Let's draw this relationship here. So this game will have a status ID. And I think that's, good enough. We might add maybe I'll just add it here real quick, created on. Some of these other tables we might have some created ons, and actually let's go back down to the moves because we want our moves to have an order here so that we know the game state. That's important. So let's add another column in here. We'll also just call this created on. And so the order of the game moves will go by the date that they were created. So this is our starting sketch of our database. I'm going to link this model in the description, and definitely feel free to comment on it. Talk about things that I missed, talk about things that you liked or that you didn't like or whatever. And I will take your feedback into consideration as we go on to next week, where we actually start building the database and creating the models. So I also want to say that we are going to be using Entity Framework Core in this. I know that there was some interest in doing something like Dapper, but honestly, I really like Entity Framework. I'm also way more familiar with Entity Framework than I am with Dapper. And we're also going to be using the identity database that's scaffolded out with the .NET identity system. So I think it just makes sense for us to use Entity Framework for this. So anyway, thanks so much for watching this episode, and I will see you in the next one. Have a great week. Bye.